Welcome to the Cisco CCNP ENCOR course, the foundation of advanced enterprise networking. The focus is on enterprise design principles, virtualization technologies, infrastructure components, and secure connectivity. You will explore high availability, SD-WAN, SD-Access, and automation concepts that shape today's enterprise networks. This knowledge is vital because networks are evolving into intelligent, software-driven, and cloud-integrated systems. We will balance theory with practical demonstrations, ensuring concepts are not only learned but applied effectively. The course supports both your technical growth and your career advancement towards Cisco professional certification. In summary, CCNP ENCOR prepares you to design, secure, and operate enterprise-class networks confidently and efficiently. Before we get into the course, a quick reminder, please subscribe to our channel. Subscribing ensures you never miss a lesson and supports us in creating more structured, exam-focused training. Your support is what makes this possible, and it motivates us to keep producing valuable content for learners like you. So hit subscribe now, and let's get started with CCNP ENCOR. Enterprise networks are designed with structured principles to balance performance, scalability, and manageability. Think of it as designing a city where roads, utilities, and districts follow an organized layout. The foundation lies in modularity, breaking the network into smaller, manageable sections. Scalability ensures that as business demands grow, the network can easily expand without redesign. Resiliency is key, ensuring the network continues to operate even when components fail. Security is woven throughout, just like checkpoints and monitoring in a well-protected city. These design principles guarantee reliable services, smooth communication, and a foundation for innovation. They are applied in enterprise LANs, WANs, data centers, and cloud architectures. In summary, applying modularity, scalability, resiliency, and security ensures enterprise networks meet evolving needs efficiently and reliably. High-level design models shape how enterprise networks are structured and managed for performance and growth. It's like building floor plans for different types of buildings, each layout serving unique needs. The two-tier design uses access and core layers, offering simplicity and cost-effectiveness for smaller networks. The three-tier model adds a distribution layer, increasing scalability and policy control for medium to large deployments. Fabric design introduces automation and policy-based overlays, simplifying segmentation and enhancing security across the enterprise. Cloud-based design extends infrastructure into public or hybrid environments, maximizing agility and reducing hardware dependency. These models allow engineers to choose the right architecture based on size, budget, and business needs. They are widely applied in campuses, data centers, and hybrid infrastructures. Ultimately, selecting between two-tier, three-tier, fabric, or cloud ensures optimized efficiency and operational alignment with organizational goals. High availability ensures enterprise networks keep running even during device or link failures. Think of it like building multiple bridges to guarantee traffic flow, even if one collapses. We'll configure a standby group to provide automatic failover. Using router iOS and by typing these commands, we assign a virtual IP, set the priority, and enable preemption. The show standby command confirms the interface state, active router, standby router, and configuration details. This output shows that if the primary router fails, another router takes over immediately, maintaining network continuity. The key takeaway is that FHRP ensures uninterrupted communication by providing seamless gateway redundancy. In conclusion, applying redundancy, FHRP, and preemption strategies ensures enterprise networks remain resilient and reliable under unexpected failures. Cisco Catalyst SD-WAN redefines how enterprises build and operate wide-area networks. Imagine replacing winding country roads with a modern highway system, ensuring faster and safer journeys. The principle revolves around separating the control and data planes. The control plane manages routing intelligence, policies, and secure connectivity between sites. The data plane forwards user traffic efficiently, prioritizing critical applications over less important ones. Security is built in, with encryption and segmentation applied end-to-end across all WAN links. The importance lies in simplifying management, improving performance, and lowering operational costs. SD-WAN is widely used for connecting branch offices, campuses, and cloud services seamlessly. In summary, Cisco Catalyst SD-WAN ensures secure, agile, and optimized WAN connectivity for modern enterprise demands. Understanding control and data planes is essential to mastering Cisco Catalyst SD-WAN. Think of it like air traffic control versus the airplanes themselves. The control plane directs, organizes, and maintains secure tunnels between devices. The vSmart controller manages routing, policies, and distributes encryption keys. The data plane consists of vEdge or Catalyst Edge devices that forward user traffic. vBond orchestrators authenticate new devices and establish initial secure connectivity. This separation enhances scalability, improves security, and simplifies troubleshooting for administrators. These elements are applied when deploying branch connectivity, cloud integration, and hybrid WAN solutions. In summary, the control plane handles intelligence, while the data plane ensures traffic delivery in SD-WAN. Cisco Catalyst SD-WAN provides many benefits, but also comes with certain limitations. Think of it as upgrading to a modern smartphone, but still depending on network coverage. The main benefit is centralized management, reducing complexity for administrators. It enhances application performance by dynamically selecting the best path for traffic. Built-in security ensures end-to-end encryption and seamless segmentation across all connections. However, it requires significant initial investment in licensing, training, and deployment planning. Legacy applications or networks may need adjustments to work effectively with SD-WAN overlays. This balance of benefits and challenges defines how enterprises adopt the solution strategically. In conclusion, Catalyst SD-WAN enables agility and efficiency, but must be aligned carefully with business needs. Cisco SD-Access transforms campus networks with automation, segmentation, and centralized control. Think of it as shifting from manual farming to fully automated smart agriculture. The principle is built on a fabric-based architecture for campus LANs. It leverages Cisco DNA Center as the controller for policy and automation. Fabric edge nodes handle user traffic, while border nodes connect to external networks. Policy-based segmentation improves security, separating users and devices dynamically without complex VLANs. This ensures simplified management, improved security posture, and consistent user experiences. SD-Access is applied in large campuses, educational institutions, and enterprise headquarters. In conclusion, SD-Access delivers automation, segmentation, and centralized management, shaping the future of campus networking. Cisco SD-Access separates control and data planes for flexibility and automation. Think of it like a smart city with planners and workers. The control plane uses Lisp for mapping identities to locations dynamically. Cisco DNA Center manages policies and automation, providing the centralized control function. The data plane is the fabric itself, built on VXLAN tunnels for user traffic. Edge nodes forward traffic, while control nodes provide endpoint mapping and reachability. This clear separation allows policy enforcement independent of underlying topology. It applies to user mobility, IoT onboarding, and secure segmentation in campus networks. In conclusion, SD-Access planes enhance automation, security, and agility in campus architectures. Integrating traditional campus networks with SD-Access requires careful interoperability planning. Think of merging manual systems with smart automation in a modern factory. Traditional networks rely on VLANs, spanning tree, and ACLs for segmentation and control. SD-Access replaces these with identity-based segmentation and fabric overlays. Interoperability is achieved through fabric border nodes connecting to legacy distribution or core layers. Traffic can pass seamlessly, while policies remain enforced by DNA Center. This hybrid approach allows gradual migration without replacing all existing infrastructure. It applies to enterprises adopting SD-Access in phases across large campuses. In summary, SD-Access, and traditional networks can interoperate smoothly, enabling step-by-step transformation. QoS ensures critical applications like voice or video get priority in congested networks. Think of it as a traffic police officer directing emergency vehicles ahead of normal cars. We'll interpret a QoS policy configuration to see traffic prioritization in action. Using router iOS and by typing these commands, we define a class map for voice traffic and apply a priority queue policy. The Show Policy Map interface command displays packet counts, match criteria, and priority bandwidth. This output confirms that voice packets are matched and guaranteed bandwidth even during heavy congestion. The takeaway is that QoS policies ensure performance for delay-sensitive applications, preventing degradation in user experience. In conclusion, interpreting QoS configurations allows engineers to verify correct policy application and confirm traffic prioritization.